Hello, fellow Econauts, and welcome back to our show. I'm here with my brother Ben, the Rocketman, and today we are talking about the planets in our solar system. Hey, Ben, how are you?
Hey Simon, how's it going? Hey fellow Econauts. Yeah, so we talked about colonization of Mars, and we thought maybe it's a good idea to have a closer look to our other planets, which we have in our solar system, and make a very quick comparison or quick assessment if it would be suitable to colonize these
Colonized.
planets as well. Colonize, yeah, colonize.
All right.
Easy.
Maybe we start with Mercury and Venus, the ones that are the closest to the sun. What about those two?
Let's start with Mercury. Mercury, the closest planet to our sun, obviously very hot. Also, the sun has a stronger pull on Mercury in general, meaning Mercury has no moons. So it's more or less impossible for Mercury to have that. The atmosphere is very fierce, so it's not very suitable for us to be there. And Venus, a little bit similar, also very close, like compared to Earth, closer to the sun, therefore way hotter, very toxic atmosphere. So yeah, Venus is also not very suitable. However, Venus is of interest for a couple of groups around the globe. Also for Russia. Russia has sent in the past a probe there. Not sure if it survived, but Venus is definitely a candidate to explore. If it's a candidate to build a colony on, that's on a different piece of paper. And also compared to Mars, obviously, Mars is way easier to do so.
Well, that brings us to our blue marble, because that's the next one in our system. So, what makes the Earth so special?
Well, Earth is very special for the following reason. We are in this so-called Goldilocks zone. We are close enough to Earth, We are close enough to the sun so that we get enough heat energy to warm up our planet. So water is liquid. At the same time, we're not too close that we are not getting too much heat. So water is liquid. It's not a gas, right? So it's not evaporated. We also have the right spin for day and night cycles. And also our moon seems to play a vital role for our planet to maintain life. So Earth is very special in these senses. And so far, we have not found, maybe we have found, but we have not conclusively found another planet in our solar system, but also in other sun systems, star systems that are that have life on the surface. So that is obviously a topic for sci-fi, but also a topic for science to find life on other planets. But yeah, so in the moment we are looking for similar planets like Earth because of these reasons.
That brings us, of course, to our favorite destination, Mars. So, so Mars is it's definitely the one that we have talked about a lot, and there's a lot of interest in Mars. Maybe you can very quickly let us know again why Mars it's a good candidate.
Yes, so Mars is, first of all, maybe a very small jump back onto to our planet. Obviously, we are now looking on to the moon, which is not a planet. That's why it's not really fair to talk about it. But the moon is sort of a petri dish to try things for Mars. And also, it will become a station or refuel station, if you want, to get to Mars. So it will be a stepping stone, almost literally. But yeah, back to Mars. Mars has two moons, just maybe for the comparison. But moreover, Mars, although a little bit smaller than Earth, has a similar size. So we would experience similar gravity on it. It has an atmosphere, although not breathable. It's not as toxic as other planets. Mars is also the last planet, like from the inner planets, that is considered terrestrial. That means it has solid surfaces where we can actually land on, which is quite important if you want to bring a spacecraft there. And yeah, so Mars has, and also the spin of Mars has we have day-night cycles and so on. Mars seems to be very suitable to at least land on, and if we dig holes for to go underground, seems to be suitable to build a colony on, which other planets in our solar system don't have. So these things are speaking for Mars. Going to another planet itself is of interest for many groups on our planet. The main reason is to make us an interplanetary species in case something happens with Earth, caused by ourselves or by other cosmic interactions. We want a backup, and Mars, because of these reasons, is a good solution for it.
Well, before we dive deeper in the reasons why we have to become an interplanetary species, let's take a look at all the other planets and why they might not be as suitable as Mars and perhaps even Venus. So let's talk about them, Jupiter and Neptune and Saturn. What is with them?
So Jupiter, Saturn, and Uranus, Neptune, they are not terrestrial anymore. So that means they're so-called gas giants or ice giants, and they're way larger than Earth. So, for example, if we just go to the next planet after Mars, Jupiter is so big. If you would make Jupiter hollow, so if you would just have the sphere, you could put 1,000 Earths inside of Jupiter. That means that the planet is 1,000 times more stronger in gravity. So if you would land as a person on that, you would weigh 1,000 times more. So now
That's what
imagine
that's what we don't want.
I'm
We
no,
all
we don't
want
want
to lose weight, not
no
gain.
also I'm 90 kilograms 90 kilograms. I'm 90 and a bit kilograms. If I would land on Jupiter, I would suddenly almost weigh a ton. Obviously, my bones and my muscles cannot lift a ton of weight. So as simple as that. Plus, as I said, it's a lot of gas and gases are on the surface, not a very suitable environment. Um, Interestingly, though, these big non-terrestrial planets, Jupiter, Saturn, Neptune, and Uranus, have a lot of moons, and they might be interesting for us. So there's, we have Europa as one of the moons of these planets, which seems to have similar um, conditions like Earth, although far further away, obviously, so less heat. But in general, the bigger planets we have in our solar system are just too big for us to stand on, and they are also not terrestrial.
You just made a very important point, I think. Um, it's also the distance, obviously, right? I mean,
Yeah, that
if
as well. Yes.
if we start the process of becoming an interplanetary species, then of course it's much easier to do so with a planet that is actually closest to us. If we look,
Yes.
and we talked about that also in our previous episode about the colony Mars. If we look at Europa as the moon, it is so much further away. If we encounter any kind of problems and issues, it's a lot more complicated to actually fix them because we are
Yes.
further away, right? So it makes sense.
Exactly.
And you also mentioned that to start with the moon, um, our moon, and then use that as a jump gate, so to speak, to get to Mars or maybe Venus, and and try our best there, right? Instead of going even further and encountering like even more problems and cannot really interact very quickly, right?
Exactly. Yeah. The moon is close enough that we could still attempt certain rescue missions. Um, I mean, obviously, it's not that we can quickly jump there. So if really severe problems appear on the lunar surface, then too bad, unfortunately. But we can test a lot of systems. We can test a lot of systems we would also need on Mars. Test them if they're secure enough, if they work for a while. There are some conditions on the moon that are even harsher than on Mars. So because there's no atmosphere on the moon, you're exposed to way more radiation from the sun, solar winds. The lunar regolith is electrostatically charged and would attach to the surfaces. Is very abrasive, very sharp. It's not like our sand from the at the beach, which is very round. They are like little sharp glass particles that are very abrasive. So, in other words, it's likely that when you build something which survives on the lunar surface, it is possible that this will also survive on Mars surface. And yeah, so we can test a lot of things. Can we attempt a rescue if something happens on Mars? Depends. Depends how long
I
lasting
think
these.
Matt Damon has
Yeah,
shown us we
yeah.
can.
Yeah, well, I mean, yeah, we can at least in sci-fi. Although the book on which the movie is based is quite scientifically accurate, but still, yeah. But it gets even worse if we go further away. Obviously, I mean that is for sure. And also, if you look at to go to other planets, it's not like, oh, we leave tomorrow and then we come there in 3 months or something. You have to have the right constellation of the planets in order to be as close as possible and to not use as much fuel or to reach it in the first place. And the further away you are, the longer it takes for these conditions to appear. So sometimes if you lose that window when you can launch, sometimes you have to wait a couple of years if you go for further away planets before you actually can attempt another rescue. It's not just the distance itself. So it's not just, oh, we need 3 months to go there, 6 months to go there. It's also, no, we cannot go at any given moment. We have to wait for certain conditions. So there's lots of things to consider.
I think one thing that we always like to do is like finding, or at least from my point of view, because I'm not the scientist, I always like to explain certain things. I explain certain things with everyday comparison. And what I just realized is if you are planning a camping trip, you wouldn't do that in winter. You would probably do that in summer. If you plan a camping trip, you would make sure that you have like everything that you need already packed, ready to go before you even go on your journey. And I think that's like a very similar case here. If you go to Mars, you need to have like certain, tools and machines and what have you available to actually survive on Mars, right?
Yeah.
As you have to survive in the wilderness if you go
Yes.
camping, right? You will have to have a tent, you will have to have fresh water, you will have to have, food. Otherwise, you will not survive, right? And that's
Yes.
I think
Yes. Yes.
that's might be a good comparison here.
Well, one thing in order to survive is you need perfection. Perfection doesn't mean how many things can you add to make better. Perfection means how many things can you take away so that it still works. And so keeping at your camping analogy, if you want to become somebody who can survive in the wilderness with only a knife, you don't start with that, right? You don't start with, oh, I'm taking a knife and I'm jumping right into the wilderness. When you want to teach your kids to camp in the wild, you don't start taking your kids and go to the wild. You first start with, you take as many things with you as possible, like bandages and food and water and a tent and whatnot, before you start reducing things. Even then, on Earth, you might get away with just a knife. Obviously, on Mars, you don't get away with just a knife. You need also you need air, otherwise you can't breathe and stuff like that. So you have to find the perfection in taking as little as possible with you, while still guaranteeing survival. So I think that's the best way to phrase it.
That was definitely an interesting episode again. Um, that's the reason why we have to go to Mars. right here. And I hope you like this episode as well. I have to wrap it up, otherwise we are going way off topic again.
Into the Mars
in
rabbit hole.
into the Mars rabbit hole. I just wanted to say, you if you plan a camping trip and your kid is called Angus MacGyver, then it might be a possibility to just give him a
I have a
knife and
feather in the spring.
here you go. You can survive. Here you go. But now, okay, let's wrap it up. Okay, if you like this episode, please don't forget to leave a like and subscribe if you haven't already.
Don't forget to hit the notification bell, leave a comment, and obviously we have already a number of episodes we would like you to invite to watch them as well.
All right. And I hope I see you next time. Have a good one. Bye bye.
Bye.